We've got this green park bench with 5 opinionated individuals who will rotate through the session. The way the rotation works, the same as on previous years, you, the audience, can ask a question for the panel to discuss. If you accidentally or deliberately proffer an opinion instead of asking a question,
or
as well as, then one of these people comes down and you go up, okay? You might do that deliberately, you might do that accidentally. I'm the final judge of that, please. When you ask your questions, please ask your question into this microphone, okay? Okay, so 3 microphones, 5 speakers. Can you introduce yourself in 1 sentence?
I'm Simon Peyton-Jones. I've helped design Haskell.
I'm Chris Jenkins. I work for TWI, doing a mixture of Haskell and PureScript.
I'm Tim Williams. I work for Standard Chartered, been doing professional Haskell for about 7 or so years now.
I'm Roman Lishinsky. I work for Facebook with Haskell sometimes. And before that, I used to do high-performance programming in Haskell and so on.
Got my own. Hi, I'm Sarah. I guess I started out as just a very enthusiastic enthusiast, but now I've had around half a year or so to work with Haskell professionally, so it's been really cool.
And are you more enthusiastic or less enthusiastic now?
Oh, a lot more.
Okay, good. Just checking.
Okay, so would anyone like to offer a starting question before I summon my stooge? Okay, I'm just going to drop down here.
Hello. What's your favorite thing that has happened in the Haskell world, either community or technically, in the last year since HaskellX 2018?
I'm not sure this is the last year, but I implemented quantified constraints in GHC. It's probably a little bit more than a year ago now. What I enjoyed about it particularly was, number one, it just fitted in exactly. It felt as if it had been something that we wanted to do for ages, and then usually my experience is, I think, oh, how hard can it be? And it turns out to be really much harder to implement. In fact, this was the other way around. That was very, and then I had this experience of meeting Patrick Ricks, I think, from GitHub, at Strange Loop, and he said to me, Simon, when is GHC 8.6 going to be out? Because we cannot wait for quantified constraints. And I'm thinking, guys, I thought that one PhD student in, Mongolia would use this thing that I thought was so cool. And there was GitHub one, so I thought that was really cool. That made my day.
I've got one, actually. My favourite things past year is I was with Neil at Digital Asset for a few months this year, and Neil was spearheading some IDE work with a few others, and there's been some real positive work done there on making a reusable IDE engine which uses incremental computation, and it will support language server protocol and a few other things, which means be usable from Emacs to VS Code to other editors. So yeah, there's been been a lot of work in the IDE side of things, which I think is good.
I'm not sure this counts as this year, but it does for me. I think my favorite thing was the book Thinking in Types, which is a book about trying to make dependent type programming useful and understandable. And that was really incredibly lucid for me. I find a lot of the dependent type stuff to be inaccessible or astronaut programming. And it was just a really good, readable book, and I would thoroughly recommend it to anyone who's interested in that.
No more opinions?
I would also say the Haskell IDE stuff has been really exciting. Another thing that I don't think necessarily counts as this year, though I think it has been improved this year, is typed holds and the suggestions you get for filling them. That's by far my favorite thing in GHC, I think, and that I always miss when I go to any other language.
You have no.
I don't know what happened in Haskell in the last year or exactly. But actually that's a good thing, I think, because it means that we can just work in the language without waiting for the newest GHT release and not be constrained by what's already there.
Okay. Anybody else?
What is the next big improvement of GHC in terms of syntactic sugar, perhaps, that you think Haskell should have next?
There might be opinions out here too, right?
Records.
Records.
Neil Mitchell has a talk tomorrow about records.
As a community, how well have we been able to avoid success at all costs recently?
Well, I guess I could mention as an experience I've had from work now, onboarding people to the projects we have. I would say we've done pretty poorly at that because it's been very easy to get people up to speed in a production environment. So you need to get on that.
So I think Haskell is almost as difficult to integrate into an existing kind of built and continuous integration environment as it used to be. So we've avoided success there quite well.
I think I'd say, the avoid success at all costs thing, it's kind of, isn't it just a joke for we're not going to become popular at the sake of the language? And I think they've done a really...
Depends where you put
The parentheses.
brackets. Exactly, yeah. The parentheses.
Yeah.
And
Implicit parentheses.
Yeah, I think we have avoided success at all costs because we don't have null, we don't have support for objects.
The language is still progressing, but we haven't diluted it. Right?
Well, we haven't pandered, we haven't removed operator overloading, or that I think we've kept it true to our vision of what we want. It's made by the community for the community, which I think a lot of languages that where languages fail, in my opinion, is where they try to pander to a particular audience, and you have a group of architects in an ivory tower that write down what they think the people, the great unwashed, need or want. And Haskell is, to me, it feels like something made by compiler writers for compiler writers. And if you think of your problem as being an interpreter or a compiler, which I do, if you think of every problem that way, it's a fantastic fit.
So one piece of success that I think has happened quite a lot in the last couple of years is that more people contribute to GHC as contributing patches, and also through the GHC proposals process, contributing ideas for language development. And that I think we need more help from all of you guys, because our principal problem at the moment is actually not so much getting contributions, but review bandwidth, right? It's there's quite a lot of people who are contributing to GHC and then feel sort of stuck somehow because nobody's reviewing their patch, or they make some interesting language proposal which not enough people are commenting on and sort of thrashing out. The thrashing out process is something that needs lots of people, who are with smart people like you guys. So, and there's a tendency to think that some small cadre of people like Richard Eisenberg will review everything, but there is only a limited number of hours that people have. So, review bandwidth is something we could the success that we've had is on contribution, and I think we need a bit more success on review bandwidth.
Where should we go to join in, Simon?
So the GitLab bug tracker for GHC is the place, up to 17,000, I think, at the moment. And the GHC proposals, just type in GHC proposals, and there's a website for that, which is, again, GitHub-based for, and we're up to, what is it, a couple of hundred proposals? I mean, it's really a lot. So or it's more like 300. I mean, so some of them are accepted, some of them rejected, but there's still quite a lot in play. So there's a lot going on. So as a laboratory for exploring ideas, very active. Yeah. But we need review, thoughtful review bandwidth.
Is Haskell still a language suitable for writing high-performance applications, and should it and will it continue to be in the future?
Define high performance. I mean, there are different things there, right? So there are high performance web servers, for example, which are a completely different thing from a numerical high performance thing, right? I think Haskell is quite suitable for writing high performance web servers in, apart from the garbage collection problem, which might or might not be solved at some point. In like numerical, traditional high performance stuff, I don't think there has been all that much work recently, but when I think the landscape has shifted there quite a bit, where you kind of move like AI workloads onto TPUs, for example, and other numerical things onto GPUs, and there are specialized libraries for that, and they're mostly in Python, so Haskell as a language would be suitable for that, but I think the library support is not that good.
I would say yes. So I mean, in the big picture of things, I don't mean that, all the tooling is there at the moment, but I think in the big picture, that if you want to optimize a high-performance program, then starting from a functional programming base rather than an imperative fabric is going to be really good for you. Now, it still means lots of legwork in actually figuring out how to optimize this stuff, but it seems like a good starting point. And there's plenty of demonstrations that Haskell is good enough for a very wide class of applications, and there's some demonstrations of it being really good for particular classes if you focus narrowly on, even on numerical, that repr and accelerate and so forth. You can get really good. You have to be quite narrow to do really well. But then, then again, it's up to the people in this room and beyond it to think, how could we broaden that class?
One thing we could do with, actually, Simon, maybe this is a proposal, but compiler pragmas to guarantee that certain optimizations fire, perhaps.
Yes.
If we have a bit of code that guarantees that, or absolutely needs this, fold fusion to work,
Yeah.
because I think that would help a lot. But we have to remember that Haskell's 1,000 times faster than Python, and Python's taking over the world. So
let's not forget that, right?
A lot of the code that we use, at our company, we use Haskell to sort of script things, and the very high performance code is often written in C, but Haskell still has there's still an enormous role that Haskell could play in sort of scripting these things up, and just as Python is doing, as Roman said, for machine learning.
Hi. What's your opinion on the Haskell language report? Does that still make sense, considering the fact that GHC is the only relevant Haskell compiler?
Well, it's not the only relevant one inside Standard Chartered. So I think it would be great if the standard was updated, because I think having competing compilers is a very healthy thing for Haskell, the language. Yes, so I think it would be a good thing.
I think even with just GHC as a Haskell compiler, having a specification of what things mean will at least allow you to see that GHC 9.5 is broken and GHC 9.3 still works.
Yeah, and having standard set of imports as well, because it's really annoying to put all those pragmas to have language extensions. If there was a Haskell 2020 with a standard set of language extensions that we all agree is a good idea, I think that would be a small win as well.
People have even suggested having language extension synonyms as an extension. And then you need ways of importing and exporting those, and so.
I was just going to say, do you not think it's a bit optimistic to all agree a set of extensions by 2020?
Well, isn't there a flag in GHC for just all of them? Or
Not yet. So, but I mean, really, it's a social problem, not a technical one. So, I think it would be, like you say, quite valuable to have a thoughtful and more thorough specification of what Haskell is. I think, as Richard said in his talk, one of the good things about Haskell is that really very many of the language features have peer-reviewed literature describing them. So, I mean, quantified constraints is one written by Tom Shrivers and his colleagues. But there isn't anything that describes it altogether as a whole. The trouble is, and the social problem is, that there aren't enough people who perceive it as being in their personal interest and motivation to spend the large number of person hours it takes to do that. When Haskell was young, there was why was I motivated to do that? Because at that time Haskell was being born. We're trying to say, what is it? And now it's hard to find people who are really motivated to do it. So that, I think, is the principal social problem. There isn't enough brownie points in it. I don't know how to fix that, actually.
Do you think that things like type-level programming and new features get a disproportionate amount of attention when compared to perhaps more practical concerns like good practices and good modeling design patterns in Haskell? And do you think that that is a problem?
I think it's true that the best practice is still being worked out.
Okay. Who wants to come down first?
It was an opinionated question, wasn't it?
It was. Welcome.
I think the best practice is still being worked out with many features. So when a new feature comes, I think it takes many years and many libraries to fully realize that feature. I mean, if you look at GADTs, for example, that's been in GHC for a long time now, but the libraries to take advantage of it, you imagine all these type-indexed containers or type classes for type-indexed types, they're still not largely there yet. So I think it takes a long time for best practice to emerge and to support some of these advanced features. I also think that also many of these features for industrial programming, there are some areas that I feel could get more exposure. Records, particularly having a being able to type a SQL query or something like that is something that can just about be done in Haskell, but it's very tricky, and you lose a lot of type inference, and more support from the type checker would help there. So there's definitely type level things that I'd like to see still happen in Haskell. But I think that's separate to working out the best practice. I think you've got to deliver them almost as extensions and then have the community play with them for years and years to see the best practice emerge.
I think there's a kind of, you take a conference like this, there are a lot of expert level programmers that you will know from previous years. And it seems like the audience makeup is probably fairly well advanced on the whole. Of course, there'll be new people, and welcome to new people. And we want to bring more of you in, but as you're thinking of submitting a talk for something like this, say, which is visible, you're thinking about the audience, and most of them are already using Haskell, fairly comfortable with it, are more interested in the bleeding edge type stuff. I remember when I was quite active in the Clojure community, and there was definitely more of new to the language, want to get working with it community. Like the proportion of experts was lower, the proportion of enthusiastic beginners was much higher. And so you did tailor talks, blog posts, anything you wanted to say to your community towards a more beginner audience. Which is to say, I think the balance is off, but I think if next year there was a sudden influx of new Haskell programmers, you'd see the talk lineup react to that. I don't know what's going to cause more demand, other than a new audience, a new demographic of audience. I don't know what's going to cause more demand for introductory and mid-level talks.
Chris, just in response to that, what was an excellent answer, I'd actually be quite interested in the makeup of the audience currently, and by a show of hands, how many of you would describe yourself as a Haskell expert? Because I certainly would. And those of you who are brave enough, any Haskell beginners, I'd probably still consider myself. Okay.
Oh, come on, Abby. That's a bad definition.
I was just interested in the response.
But do you think that things like modeling patterns and do you think that things like modeling patterns and best practices are for beginners? Aren't these things that you end up having competing solutions that even people who are very advanced would profit from being reminded of them or acquainted with new ones of those?
I think there's a big gap between. I found there was a big gap. I started with Learn Your Haskell or Real World Haskell. You start from those books, and there is a big gap going from I understand the basics of the language. I understand Haskell 98-ish, and actually solving today's problem with it. I think there's a gap there in that market, and I'd quite like to see some books for shipping Haskell, right? That would be a nice book to read. If anyone wants to write it, that'd be great.
So talking about type systems extensions, so the way I see it, right, you write your code that implements things in Haskell, but you express your design in the types, right? So that's how I use types as a programming language for expressing design most of the time. And I think the reason why there are so many extensions is because it's still not quite right. There are designs which I can't express in there. And so that's, I guess, why there is such interest in it. So it's not just a theoretical interest in type systems, I think. It's also, so from my point of view, it's a practical interest in being able to express the right design in your types. And then, when you're refactoring, for example, to have the compiler check that what you're doing actually corresponds to the design that you have. And I think that's also missing from literature to some extent. So there are certainly a lot of papers that describe type system extensions, but there is nothing that says, well, if this is what you want to do, this is how you encode it in the types. And I think that's something that would be quite valuable to have.
I think we do have some talks that talk about this sort of thing. Duncan is doing a talk where he's going to talk about encoding types, state machines and so on, and having the protocols verified by the type system. So yeah, there are. I think we do have some talks like this, but I enjoy the balance of academic and industrial. I enjoy the mix with this conference. I think it's a very healthy mix to have academics engage with industry and meet in the same place as industry, and that's one of the great things about this conference, I think.
Yes, so my question is related, but not the same question that the previous one. Who would you say the people, the resources, and the communities that are dedicated to the vulgarization and the teaching of concepts that emerge in Haskell?
I missed the last part of the question.
So I'm interested in the vulgarization and teaching of Haskell, and I would like to know which people and communities and resources can help me learn more and connect more about these aspects.
There was one keyword there that I didn't understand. You're interested in who is responsible for?
No, in who is
the regularization of the language.
Sorry, I didn't say regularization. It's vulgarization, propagation, if you want.
Okay. Like how the community expands, or how people get to know about Haskell.
how people teach Haskell and how people make the concepts that emerge in Haskell more accessible to others?
I think that is mostly an open effort of the community, right? So people write blog posts explaining concepts, and there are conferences like this one where people usually get a complicated concept, and distill it into easier, in an easier way. I think.
Yeah, there's still monthly meetups happening in London about it. There probably aren't enough practice groups, I think, in London. We could do with more getting past the basics to actually using it type stuff.
There is Hoodlums at Barclays, which takes place once a month, and you can find that on Meetup. And that's a sort of a coding dojo style thing where this sort of thing is discussed. But I think there are quite a few different sort of. I think there are many thought leaders in Haskell world in terms of how to build programs with Haskell, and there are there's lots of blog posts and some tricky some ideas about lenses and things have been come from both academia and also people tinkering in their spare time. I think I definitely think it's the whole community that shapes the best practice and so on.
Yeah, it's unlike you have languages like Elm, for example, who have some core developers who are actively engaged in trying to get the language to be spread and to promote the language in different countries, and then afterwards it started growing as more of a community effort. In Haskell it feels that's much more organic in this sense.
Yeah, it doesn't feel like there are central evangelists. Elm definitely has a couple of big name evangelists. PureScript probably does too. I don't think Haskell does so much. The first name that comes to mind would be Ollie Charles, but we burnt him out years ago.
Yeah, I would agree that it's very much a community thing, and I would kind of want to, turn that back to all of you. There were a lot of people raising their hands saying, yeah, I would say I'm a Haskell expert, and so some stuff I've done is to, or stuff you can do is to just start a little study group or something, if you, either at work or in your local community. If you know some people who are interested in Haskell or who have done some stuff but aren't sure how to take that next step, making the effort to kind of come together and just talk about it and share your experiences, I think is a really important step in kind of spreading it all and kind of coming to some, maybe not global consensus, but at least, come together in large groups and then see what happens from there.
So my question is about performance debugging. How often did you have to do performance debugging in your professional Haskell life? And how did it work out for you? Did you pick up any tricks that you could share with us that you think is important to know if you want to do performance debugging?
Well, Roman probably knows Core more better than Haskell, yeah?
So I've done quite a bit of performance debugging in Haskell in my career, but I have to say in my professional career, I've probably done more C++ performance debugging than Haskell for reasons which have to do with C++, which also probably have to do with the fact that there is a lot of code that's supposed to be high performance that's written in C++. For Haskell, yeah, you kind of, to be honest, it's mostly the same as for other languages for me. So like in C++, I don't go off and use a profiler because most of the time that doesn't tell me anything and can't even run it. So you just insert maybe printfs which tell you how long things take. It's the same as I do in Haskell a lot of the time. Haskell has heap profiling, which is much more helpful than anything else I've seen. So if you see that something allocates a lot that you don't expect to be, then that might be an indication that something is wrong. But in general, so I personally have never found it to be a problem compared to other languages. It is a problem because it's a problem in general, but I have never found it to be a larger problem than in other languages.
Yeah, I would agree with that. I mean, I've years and years ago when I was doing C++ and Java, we had tools to do profiling, and the Haskell versions are slightly clunkier, but they do the same thing. And you know, I've have had to track down a few space leaks from time to time, but it's never been a huge issue.
Yeah, I'd echo that. It's if anything, I've had slightly fewer performance problems with Haskell, but whilst sometimes the causes of performance problems are counterintuitive, if you've come from something like C or Java, then no worse.
Yes, in fact, laziness has probably solved more performance problems for me than caused them, because often you can write some really naive code and laziness just makes it efficient. And it's something that is easy to forget.
My first experience with debugging production Haskell was I had this thing that was loading in, it was basically an ETL program. It loaded in a big database of property data, stuck it in a Postgres database. And it was failing because basically the files were something like 5 gig, and it was just filling up with memory and falling over. And I used it as an excuse to rewrite it using pipes. So I probably spent half a day rewriting the code so it would load this file in. And I started it running and scrolled through the process list to try and find where my program was in memory usage, and it wasn't at the top. And I went all the way down to the shell that was invoking the Haskell program, and that was using more memory than the thing which was now basically just using one record at a time's worth of memory. And it was neater code, right? So you can ordinary, everyday, not high-performance computing, but day job Haskell can be very maintainable and very performant.
One thing I'd like to add is that I always found that like compositionality is an important property of the software that I write, so that you can compose things. And if you care about performance, then strict functions don't compose, whereas lazy ones do.
I guess I can say real quick to the experience I've had so far, which might not be as many years as other people, but most problems I've had relating to performance or bugs overall have come from the infrastructure and the deployment and everything around. The Haskell code is usually fine. It sits there and it works and it's pretty fast and performant, and everything else is burning, you know, around it.
So why is nowadays VS Code the best IDE for coding Haskell?
You're just trying to get up here. Come on, that's an opinion.
Yeah.
The answer is because you haven't used Emacs.
So one thing that I enjoyed a lot when I used VS Code the last time, so it had been a long time since I had used VS Code for Haskell. And then, actually, I should preface this. I was using VS Code for Haskell with Nixos, and it was a little bit painful, maybe because I'm just not good enough at using Nix. But then after switching to something that is not Nix, so everything just work out of the box, I was surprised to see that actually things just work out of the box with VS Code. As long as your project builds with Stack, it just works. Whereas I used to be a Emacs user, and I remember it was a little bit more painful to set it up. I don't know if that's still the case.
I can say no, it's great that it works out of the box. That's fantastic. But it won't stop me using Emacs.
I don't like IDEs.
In which ways do strict functions not compose? What?
If you do map in a strict language, you will materialize the entire temporary list, whereas in a lazy language, you will not.
Leonard Augustin did a nice blog about this a few years ago. More points for lazy evaluation or something it was called, but yeah, it's true. Strictness is a problem for composition. I think in Java, of course, and languages like that, they implement lazy evaluation on top of their sort of strict call by value system. So they have iterators, for example. So they recover lazy evaluation that way. So then they can map over streams and iterators. So yeah, really, any modern language has ways of getting laziness. Often through a library.
If I may, no, that's obviously not going to be a question, so maybe I should just stand up right now. I guess Abby will want to get the mic back, but I program in 2 programming languages, usually. Abby, where are you? Oh, here you are.
But continue to speak into the mic and then go.
Yeah.
There we go. Who's swapping out? No, you can't. You.
Oh, no. Oh, yeah. One of them is Haskell, and the other one is OCaml. Yeah, it exists. So one of them is a pure lazy functional programming language. The other one is a not really pure and strict programming language. And there's a difference that there's not between these 2 languages. It's composition. And yes, if you want to map things, it's better to go through iterators. But again, they exist, like in Java, and I mean, you don't even need. I mean, most of the time, when you want to iterate over something, you're going to do a single traversal, so you don't need memorization and all these things. I mean, memorization that you're sharing things, because you're going to use them only once. So it's even very, very cheap, and it's easier than the entire black holing sort of story that we have in Haskell. So if it's just about mapping, it's a very small argument. And if you're going to pay the price, I mean, opinions might differ on what the price is. But for me, the price of laziness is you get very, very terrible item bugs from time to time. But the most interesting thing about that is the regular professional or semi-professional discussions of people patching a bit of code and saying, is there a memory leak in this code? And then they're like experts just trying to figure it out. And it's really, really, really hard to know whether there's a memory leak in a lazy code. So so I couldn't speak about that for an hour. I'm not going to. So I'm going to stop here and leave the bench to other.
But couldn't a sufficiently smart compiler solve that?
I guess depends on how sufficiently smart you might accept. I mean, some things are undecidable. If you accept your compiler to decide an undecidable problem, then we'll solve a lot of problems. And what is that? I mean, you said it solved that, but I'm not sure what that is.
Well, usually there are, when doing functional programming, we just usually don't care about, we try not to care about how things will actually work out in runtime, and we just hope that a compiler will figure out what is best for us.
In the attempt of avoiding another half-hour-long rant, I don't. Of course you care about how the program executes.
Maybe you need more control about what transformations GHC is doing and whether it should be doing them and what it floats out and what it doesn't. And
no, I don't disagree with this. My point is that justifying laziness on account that it is more composable because you can do map of map is a very weak
argument. It's just one small example.
Well, it is sort of the example.
Well, it's not necessarily, but of course it's a simplified example. But as you said, and as Dim said, other languages, when it comes to iteration over data structures, for example, implement things which kind of resemble laziness, right? And which, of course, come with all the same problems that laziness has. So if you have a code with iterators in pick your language, and you ask, does that have a memory leak? You will have exactly the same problems as in Haskell. Right? Now, composition, I can give you another example of composition which doesn't have...
At this juncture, may I suggest that we move on?
Yes.
Okay. We have a ton of questions to get through in the next 15 minutes, so I'll pass on to the next one. It was a fascinating subject, which I'm sure we can all discuss over beer after the park bench.
So it appears to me that there is currently quite a discrepancy in the way Haskell is applied to different sectors. Like there is the banking sector and like the rest. So I was wondering if maybe you had an idea of why it is like that. So what is much popular in the banking sector than other sector? Are there historical reasons, or is it pure luck? Or
So I can speak about the banking sector. In a bank, the business has more power than an IT architect does. So if the business have, at Barclays, one of the heads of business had an old friend from university that was a computer science professor, and he was using Haskell. So the guy said, "Right, I want Haskell, in the bank, and I want to use it to describe my financial products because my friend in the pub told me about this paper, composing contracts, and I want that here." And there's nothing an IT architect in the bank could do to stop it. Yeah. So that was the story at Barclays. They have been successful in stopping it spreading, unfortunately. And Standard Chartered, it was similar. It came from the quant team, and the use of Haskell came from the quant team, and there the quants have a lot of power because they write the code that is the crown jewels of the bank. The pricing and risk is what the bank do to often get a competitive advantage. What it used to be, now it's about avoiding fines, but it used to be that pricing and risk routines, were seen as a competitive advantage. So those guys had a lot of power, and they could bring in Haskell and use it, and there's nothing the IT architects could do about it. So that's how I got into banking. I can't comment on the other anywhere else.
I think they're solving different sets of problems. So banking are mostly about gluing things together, which have been written by other people, whereas like in the company where I work at, it's mostly about massively distributed systems, and they're different sets of problems with different sets of solutions.
I think it's very unlikely. I haven't seen that many. There's thousands of Haskell code base. I've seen a few dozens, and my impression is that there's no two kinds of Haskells. There's way more than this. It's because it's a very powerful programming language. You can do a ton of things with it, and there's no reason for two code bases to look alike.
More seriously, it was a brilliant fit at Barclays because we could build a compiler with it. That's what they're doing at Barclays. They're taking descriptions of trades and compiling it into a generic representation that can then be interpreted in many different ways. It's similar to how the composing contracts paper talks about at Standard Chartered, and so Haskell obviously was a fantastic fit for that. At Standard Chartered, it's a fantastic fit because in finance you really want functions to be pure. You want to be able to reproduce the price or the risk the next day. Whereas if your code is grabbing the time from somewhere or a date from thin air, or it's going off and loading some bit of data from the network somewhere, and you don't know about it, and then you don't have reproducible numbers. So I think it's a very good fit in finance. At least at Standard Chartered, we thought so. It really is an asset. I'm joking a bit with the IT architects, but the reason why it survives in both places for more than 10 years is because it's worked out. It's worked out well, and it's a competitive advantages for both banks. And I pity those banks out there. You know who you are that use Python. Millions of lines of code written in Python by thousands of developers. I will never join one of those banks. Never.
And I think also that banks just have more money to hire more people and do more PR as well. There certainly are a lot of small companies out there using Haskell we never hear about. I'm pretty sure that if somebody from Well-Typed or FP Complete was here, they would be able to give us more examples about is more people needing Haskell, but just not showing up to big conferences.
There's several Haskell consultants in this room and one on this bench.
That was your cue.
That was a cue. Again, there's plenty, and the person who asked the question is, sorry. Also, the person who asked the question is one of these consultant people with weird PCs. Seriously, okay. Here, is it better? I can hear myself. That's horrible. Yeah, so there's plenty of needs. The most common need that I've seen in practice is, oh, I think Haskell is cool, let's do it. It's not like you can write your code in three or four languages of different kinds and choose which one is best for you. You go with your guts. And very often it's like the first serious Haskell project of that person, like besides school or that group. So it's mostly a leap of faith. And when it's done, it's done. So there's no real reason why people pick Haskell. We're not that clairvoyant, I mean, as a species.
Yeah, I'm sort of sorry to single out one panel member here, but Tim, you just said that it would be really great if there would be multiple Haskell compilers out there, or the panel agreed, it seems. So there's this bank, which has a production level Haskell compiler. Also, it implements a version of Haskell, which was earlier discussed, its strict version. It's sort of production ready. So what would it take for Standard Charter to contribute that to the community?
Well, unfortunately, we have a mono repo, and it's in the same repo, full of lots of, as I said, proprietary, top secret quant code, and so it's very difficult to. It would be very difficult to open source it because it's the quant repo, so it's the hardest thing. We would have to take it out of that repository, and then we don't have a mono repo anymore. And yeah, so and also it's not really. It wouldn't necessarily add anything new to the community. It's tied to a runtime that wasn't designed for Haskell, and it's just a simpler Haskell than GHC. I don't think it really. It uses a lot of Hackish packages like the parser is all Haskell source extensions. I don't think it would add a huge amount to the community anyway, but it would be very difficult for us to open source it, unfortunately. And it would be such a big decision. It would to split up the repo. Sorry about that.
Hi, I want to talk about the distributed systems. So I have two questions. So one is that, as a matter of fact, the big data community is heavily concentrated on JVM or C++. So there are any ambitions from the Haskell community to tackle one of the big data problems? And second question is, a few months ago or weeks ago, I found out a new project named Unison. It's a language trying to express distributed system on the language level. Do any of you want to make some comments on that? Yeah. Thank you.
So, to the first part, like the big data stuff, as far as I know, is happening mostly in Python as well, and against library support, right? So, like, if you look at, I don't know, if you look at something like TensorFlow, right, that could be implemented in any language because it's basically a compiler, right? So it happened to be implemented in Python because that's what the people who started it knew it, but now you just can't compete with it for the things that it does, right? Because there is so many man-years of work in that thing that it's difficult to recreate, and the language that it's in doesn't really matter all that much for the things that you do in it. As to expressing distributed systems in a language, I mean, I'm not familiar with your project, right? But like at least where I work, one of the requirements is that, of course, different systems are written in different languages. So if you just have one language, which I don't know again if that's the case for your project, but having one language in which all parts of a massively distributed system must be written doesn't really work in a lot of places, I think.
Do you think there's a gap between what we as Haskell programmers and the Haskell community think and believe about working with Haskell and what people outside the community think and believe about Haskell?
Yes. Okay. Look, there's not much to say about this. It's quite obvious when you talk to people, especially like I don't know.
Put the microphone closer to
I'm bad at this microphone thing. That's, okay. Yeah, it's obvious. My experience with Haskell is very different from how people describe it when they don't program in Haskell. And something I like to repeat is I don't program in Haskell because it's hard. I program in Haskell because it's easy. With the caveat, I recognize that Haskell is a bit hard to learn at first. Programming in it is not hard. And type systems don't make less programs expressible. It makes more program practically writable. And so it is definitely true that our experience as professional Haskell programmers is vastly different to what people that never did any Haskell or only in the university imagine that it is. That being said, both positively and negatively.
Yeah, no, that's true. I couldn't say it better myself. The people, I think, are put off by the learning curve. Many people they must think it's hard. It's for computer science PhDs only, perhaps. I don't know. Maybe that's going a bit too far. For me, I couldn't imagine solving difficult problems in any other language. I just don't know how people write compilers in C, or it seems they must be very skilled programmers, and Haskell enables an average programmer such as myself to be able to tackle very complicated problems, and it's been my secret weapon at work, really, because I can tackle quite difficult problems with a mediocre brain. And people won't understand that until they've tried it. You know, how do you convince somebody that the learning curve is worth it if they can't see what's at the end of the tunnel? It's a tough problem. I don't have the answer.
I think that there is also an intersection between what we're talking right now and natural languages and how natural languages shape thought. So for example, if you learn a given subject on a given language and you're speaking a different language, when you think about that subject, your brain might switch back to that language. I think there's a lot that we don't know about in terms of the connection between language and thought. And programming languages, as it says in the name, they are languages. And I'm not saying that people are more or less adaptable to the Haskell language, or that Haskell changes how you think. I think that maybe there's both things in play here. What I definitely do know is that for myself, if I'm writing, let's say, C, oftentimes I think about how to solve a given problem in Haskell first, and then I have to think about, okay, but this is not Haskell. I have to think about how to do it in C. But then again, I have been programming in Haskell way more than C. So just like sometimes even though English is not my first language, since that's what I use all the time, sometimes I'm speaking another language and then I just think about something in English and I have to translate it back. So I think there's a lot of similar concepts between natural language acquisition and learning about programming languages and also applying them and how that helps or hinders your thoughts about a given problem. And surely there is a lot that we still have to learn about this.
And also, just to agreeing with Tim as well, that it is inevitable that people who have very little exposure to something will have some preconceived notion of it. So it is not a particular privilege of Haskell, but of any other thing in the world. If you have little exposure to it, you have some notion of it in your head that probably might be very far away from what it is in reality. So the only way to counter that would be for Haskell to be extremely popular, so everyone would know a Haskell programmer and know how he looks like and how he thinks, and then they would probably have a notion of what a Haskell programmer is, or what the work of working with Haskell is like. But other than that, it would be very hard to change people's preconceived notion of our community, which is not as big as the JavaScript community, for example.
Yeah, it's quite interesting when you see online people talk about pure functional programming. You know, you can't just use one paradigm for all programming. You know, they don't understand. There's many people out there that just don't understand that actually Haskell now is multi-paradigm. It's a lot of code that we write in Haskell is imperative, and it works just fine. And there's a lot of preconceived notions out there about what Haskell is capable of, and yeah, it's a marketing problem, really.
Okay, so, I was going to say our time's up, but there's a Duncan at the back waving his hand. We got one more? Okay, we've got 10 seconds. Yeah. Okay.
So for the camera, Duncan just said that, quoting someone sitting in the room, Haskell is the finest. Yeah, Haskell is the finest imperative programming language.
Yeah, but with all due respect to Simon, he's biased. Yeah. I'm somebody that used to do C++ and Java, and I'm saying it's the world's best imperative programming language.
Okay, last question, and short answers, so don't ask a difficult question.
All right, so, okay, easy one, maybe. I was going to ask, well, okay, let's phrase it shorter. How are you feeling? Are you excited about the development of dependent Haskell? Do you think it's going to be like a big paradigm shift, or is it going to be kind of a niche thing only used by a few people?
At my previous job, I was working on the Coq Proof Assistant, which is a dependently typed language. My perspective on that is it's really hard to know. Dependent types are extremely exciting. But making them work in practice is really hard, and we, as the humanity in general, we don't know how to do this yet. So if Haskell makes it work out, that would be an extremely exciting development, but it might never pan out. More than it already has, anyway, because it has brought a ton of things to Haskell.
Anyone else? Yep.
Going back to my point about using types to express designs, I don't think this works. Going back to my point about using types to express designs, I don't think dependent Haskell will help me with that, because that's not the kind of designs I necessarily want to express.
I think for us it doesn't necessarily. It's quite exciting work, of course, but it doesn't necessarily express the solve the pain points that we have with modules and records and things. So I think I'd like to see more work in that space, although perhaps it's not very. Perhaps it's not the most interesting work to do, but I still think there's still academic research to be done in those areas. You know, first-class modules and dependent types have some overlap as well. Leonard's KN language had a very good solution for modules using dependent types. So yeah, so there is some overlap, and it could solve perhaps some of the problems that we have.
I think it's super cool, especially because we have, for example, the singletons library, and which people are using for pretty cool stuff, but at the same time, it's very painful. So yeah, looking forward to that.
Okay, thanks to these panelists. Thanks to the other panelists. Thanks to Abby for managing the questions.